So we're going to finish off that released items 2016 package. I have no more left, so if you didn't get it, you can blame the people that took more than one. So I'm not going to mention any names or look at anyone in particular because that would be rude. I know that. Okay, but again, this was recorded and the notes are posted on Google Classroom as well, so you'll be able to look at the material anyways. Okay, so remember, Friday, day after tomorrow, is your diploma exam. You guys are writing in here. Exam starts at 9 a.m. You really should be here by 8:45 though, because there's some pre-exam stuff that needs to be taken care of. Calculators need to be cleared. So try and be here early. And again, you'll regret it if you don't spend as much time as you can preparing for this test. It's not going to be easy. If you know your basic stuff, you should pass. But if you want to do well, you really, really have to prepare. So that ball's in your court. So next question. You got the graphs of f and g. The range of h at x, which is f minus g, would be what? So the range are the y values. So we need to know the minimum value of y and the maximum value of y by going f minus g. So the minimum value should be able to be found by taking the minimum value of f Okay, so the minimum of h will be found by taking the minimum of f minus the minimum of g. So the minimum of f is -4 minus the minimum of g minimum of f is -4 minus, because it asks for the range, right? Yeah. So, and I guess it probably, just to be sure, it might be better to, let's see, so x goes from -2 to 2, x goes from -2 to 2, so that would be the same. Yeah, so to get the minimum value here, you'd have to take the minimum value of f, and you'd actually have to subtract +2. Because if you use -2, which is the minimum value of g, the minus minus will become a plus positive. So to get the minimum value, you'd actually have to take the minimum value of f and actually subtract not the minimum value of g, but you'll have to subtract +2, which is actually the maximum value of g. But because it's a positive value, this will give you the smallest possible number. So it's you got to kind of look at what the values are in g and then decide, well, which one is going to give you the smallest value. If you subtract -4, -4 take away -4 will actually be 0 because the minus minus will become a plus positive. So the minimum value of h will be found by going -4 take away 2, and the maximum value of h will actually be found by taking the maximum value of f, which is 8, and subtracting the minimum value of g of -4, because the minus minus will become a plus positive. So the the range will go from -6 to +12. And that's why C is the correct answer. Okay, use the following information to answer the next one. H is G plus FOG at X, and you've got F at X and G at X. What is the value of H at 5 to the nearest hundredth? So h at 5 would be found by taking g at 5, because it's g at x, plus f at g at 5. Because the other part of h at x, you need to add FOG at x. So g at 5 would be 1 over 5 minus 2, or 1/3. So you're going to take 1/3 and you're going to add what f at 1/3 is. Because again, inside this embedded function, it's f at g at 5. We've just found that g at 5 is 1/3, so now you have to go 1/3 plus f at 1/3. So it'll be 1/3 plus, when f is 1/3, it'll be 1/3 squared plus 6 times 1/3. So that'll give us 1/3 plus 1/9 plus 6 times 1/3 will be 6 over 3, which is 2. And it does ask us to write to the nearest hundredth. So we could now use our calculator and just get the decimal. So it'll be 1 over 3 plus 1 over 9 plus 2, which to the nearest hundredth would be 2.44. So remember, on a numerical response, there are 4 boxes. You go left to right. The decimal takes one of the boxes. And there's a spot below that second and third column to bubble in decimals. So you always want to make sure that you go back and check all your bubbles for multiple choice as well as numerical response. You've got 6 hours to do the exam, so go back and check everything. Number 16, an angle that is coterminal with a negative 11 pi on 4 in standard position is what? So where is negative 11 pi on 4? Well, a negative angle goes clockwise. One surround would be 8 pi on 4. Then there's 9, 10, negative 11 pi on 4 will be about right there. So which of these angles is coterminal? So the first one we need to check is 7 pi on 4. Well, that is a positive angle, so you're going to go counterclockwise, 7 pi on 4. So there's 2, 4, 6, 7 pi on 4 would end up right there in the fourth quadrant. So that's not it. So the next one is 5 pi on 4. Again, that's a positive rotation angle. So if we go 5 pi on 4, that'll be 2, that'll be 4. 5 pi on 4 does end up at the same spot. So that is the answer. 3 pi on 4 would put you in the second quadrant, and 1 pi on 4 would put you in the first quadrant. They definitely don't get to the third quadrant. All right, next question. A dog is tied to the corner of a rectangular garage. He's given enough leash to run along a 20-meter circular path, completing 3/4 of the circle as shown in the diagram below. The length of the dog's leash, which would be the radius of that to the nearest tenth of a meter, is what? So again, the circumference of 3/4 of the circle is, well, sorry, the path, yeah, the circumference of 3/4 of the circle is actually 20 meters. That's 3/4 of the circle, okay? So that means that once around the circle would be a total of 2 pi radians. This will be 3/4 of that. And that would be how we find our central angle theta. Again, one complete revolution around the circle is 2 pi radians, but this is going to be 3/4 of that. Our central angle will be 3/4 of 2 pi. So when we use our formula, A equals R theta, the arc length is 20. We want to find out what the radius is, and theta again is 2 pi times 3/4. One complete revolution around the circle is 2 pi radians, but this will be 3/4 of that. So we can simplify a little bit because you can divide top and bottom by 2. So now we can say that 20 equals 3 pi over 2r, and then we would divide both sides by 3 pi over 2, or we could multiply both sides by 2 first and get 40 equals 3 pi r, and then divide both sides by 3 pi. And when you do it in your calculator, we've done this before, you got to put the 3 pi in brackets to keep both the 3 and the pi in the denominator. So r would be 4.2 to the nearest tenth. And that would be in meters because the arc length is in meters. So remember that in this case here, the last blocks would be left blank. You put a decimal in the second box, bubble in the decimal in the second column. The last box is left empty. Next question. Unit circle shown with an angle theta in standard position. Point K, comma, 0.6 is on the terminal arm. We want to find the value of K and the exact value of secant theta. I think we've seen a question like this before in our review. Because it's a unit circle, the radius is 1. To get to this point, you're going to go K to the left and 0.6 up. So our value of K in the end will be negative, but we can find out what the absolute value of K is by using Pythagorean theorem. K squared plus 0.6 squared will equal 1 squared. So K squared plus 0.36 will equal 1. K squared will equal 0.64, so K will equal 0.8. But because you're going to the left, it'll be negative 0.8. To find the secant, we take the reciprocal of the cosine. The cosine of theta would be negative 0.8 over 1. So the secant would be 1 over negative 0.8. But note that all the choices for secant are a fraction, so let's use our calculator and go 1 divided by negative 0.8 to get the decimal, and then let's turn it to a fraction, negative 5/4. So that's why A was the correct answer. Okay. Next question. Terminal arm of an angle of 70 degrees in standard position intersects the unit circle at P with coordinates x, y. The coordinates of point P, x, y rounded to the nearest hundredth are x equals 0.AB and y equals 0.CD. So what are the values of x, which is AB, and y, which is CD? So we're going to get 2-digit numbers for each when they're rounded to the nearest hundredth. So to do this, you're just going to use your calculator. The terminal arm has an angle of 70 degrees. Remember that every stop on the unit circle, the coordinates are cos theta, comma, sine theta. I just got to fix something here. Okay, so every point on the unit circle is cos theta, comma, sine theta. In this case, the cosine is 70 degrees. So this is how we get our values of A, B, and CD. We round each of these to the nearest hundredth using the calculator. Because we're in degrees, we need to be in degree mode. So we'll take the cosine of 70 degrees, which would be 0.34. So this will be 0.34. And the sine of 70 degrees is 0.94. So you'll get 34, and then you'll get 94. So that's the code that would go in the 4 boxes. Okay, number 18. Sine of theta is negative 2 cos theta. What is the exact value of tan 2 theta? So we know that tan 2 theta, and this is on the formula sheet, so you don't have to memorize these, but tan 2 theta equals 2 tan theta over 1 minus tan squared theta. So we're going to use that. Now we're told that sine theta equals negative 2 cos theta. So if you take this and divide both sides by cos theta, on the left you have sine theta over cos theta, which is tan theta, and that equals negative 2 on the right. So wherever we see tan theta, we can replace it with negative 2. So this will be 2 times tan theta, but tan theta is negative 2 over 1 minus the tan of theta, which is negative 2, all squared. So that'll give us negative 4 over 1 minus 4 will be negative 3. When you square negative and 2, you'll get positive 4. So it's 1 minus 4, which is negative 3, and then negative divided by negative is a positive. So that's why A was the correct answer. All right, number 19. The cosecant of theta is 2 over root 3, where theta is between 0 and 2 pi. Then theta lies in which two quadrants, and the cotan of theta is equal to what? Well, if the cosecant of theta equals 2 over root 3, that would mean that the sine of theta is root 3 over 2. And because it's positive root 3 over 2, and it's the sine, that means we could either be in quadrant 1 or quadrant 2. And the two places where sine is root 3 over 2 is at 30 degrees and at 150 degrees. Because at those points, the coordinates are 1/2 comma root 3 over 2 and negative 1/2 comma root 3 over 2. Those are the two places where the sine of theta is root 3 over 2. Now at each of these points, the tangent, you might remember, was root 3 over 3. So if I do the tangent in black, it was positive root 3 over 3. And let's back up a little bit, because that actually came from 1 over root 3. And the reason I want to write it like that is because we actually want to say what the cotan is. So the cotan would be the reciprocal, which would be positive and negative root 3. So again, we have to be in quadrant 1 or 2, and the cotan is positive and negative root 3. So that's why A was the correct answer. Sorry? Oh, what did I do wrong here? The tangent, which is sine over cos, root 3 over 2 divided by a half. Yeah, I did do it wrong. It should have been root 3. Because when you multiply by the reciprocal, the root 3's cancel. So yeah, it should have been root 3. So I wrote those wrong. Just going by memory, which sometimes isn't obviously 100%. So yes. That's what the tangent is, so the cotan would be the reciprocal. Number 10. Cos of x minus 20 degrees equals a half, where x is between 0 and 90. What is the value of x? Well, this is just done once again using the unit circle. And the fact that the cosine equals 1/2 at 60 degrees. Because there, and again, let's write our rotation angle. The coordinates there are 1/2 comma root 3 over 2. So that is the cosine of 60. So x minus 20 has to equal 60. So therefore x will equal 80 degrees. Which means in this case you only have 2 digits to fill in. The last 2 boxes would be left blank. So just again recognizing that value of a half from some place on the unit circle. The next question, you've got a partial graph for that sine function. 2 of its maximum points and 2 of its minimum points are labeled. That sine function is written in the form a sine b bracket x minus c plus d. In this case here, we just want to know what the minimum value of c is. Well, remember, c refers to the phase shift. And normally the graph of sine starts in the middle going upwards. In this case here, this graph has been shifted to the right. So we need to find out what that value is. So it would be helpful to know where the middle is. The middle is halfway between the max and the min. So if you go from positive 1.5 down to negative 5.5, that's a total distance of 7 units. So the middle would be halfway between that. If we divide that by 2, we would get 3.5. So if we go 3.5 below the max or 3.5 above the minimum, we'll be at the middle. So if we start at negative 5.5 and we add 3.5, that should take us to negative 2. That's where our middle is. So we can kind of guess where that will be, approximately right there. And this is a d value of negative 2. Okay, I think that's right. Let me just check that. Negative 5.5 plus 3.5. Yeah, negative 2. So we need to basically find out where that point right there is. So let's next find the period. The period goes from negative 7 pi on 6 to 5 pi on 6. Or we could go from this minimum to that minimum. It doesn't matter. Let's find our period. by subtracting 5 pi on 6 minus negative 7 pi on 6. So that's going to give us 12 pi on 6, which is 2 pi. That's our normal period, which means our critical points will be every pi on 2. Or in this case, every 3 pi on 6. So if you go from negative pi on 6, which is that minimum, the next critical point will take you back to the middle. So from negative pi on 6, we just have to add 3 pi on 6. That'll give you 2 pi on 6, which is pi on 3. And if you go pi divided by 3 in your calculator, you should have the answer. To the nearest hundredth, 1.05 of a radian. So that's why that was the correct answer. Local park with a radius of 195 meters has a circular running trail surrounding it as shown below. The shortest distance from the running trail to the parking lot is 5 meters. At a constant speed, Ellie can complete 4 full laps of the park in 32 minutes. Ellie's distance from the parking lot as she runs in S meters as a function of time, t in minutes, can be represented by a sinusoidal function, a cosine function. Okay, and we want to find out what the values of B and D are, respectively. So, the minimum distance from the parking lot will be 5 meters. The maximum distance will be, so you got the 5 meters plus a radius of 195 plus another radius of 195, because the maximum distance will be when she's at the bottom of this circle. So 195 times 2 would be 390, plus this 5 would give us 395 meters. So that would be the max and min value of that graph. And remember, D, the horizontal midline, is halfway between the max and the min. It can be found by basically finding the average between the max and the min. You add them up and divide by 2. So that'll give you 400 divided by 2, which is 200. So that is our D value. So we can eliminate A and C. So now we just have to figure out what our B value is. Now, she does 4 full laps in 32 minutes. So one cycle will be how long it takes to do 1 lap. So one cycle, which will be our period, will be found by taking the 32 minutes for 4 laps and getting 8 minutes. 8 minutes per lap. That is our period. And remember, our B value is found by going 2 pi over the period. So 2 pi over 8 will be pi on 4. So that is our B value, and that's why C is the correct answer. Okay, question? No? So normally we said that period equals 2 pi over B, remember? But you can solve for B by multiplying both sides by B first. You'll get B times the period equals 2 pi, and then dividing both sides by the period. So that's another relationship between be 2 pi n the period. And we did this in class. Okay, we did that in class. Next question. The steps shown below were used to determine the complete solution to that equation. The first recorded error is in what step? So the first thing you would recognize that is in this case, you have two different trig functions represented. You have a sine squared and a cos squared and a sine. So I would want to put everything in terms of sine here, which I can do by replacing this cos squared x with 1 minus sine squared x. So this will leave us with 3 sine squared x plus cos squared x, which is 1 minus sine squared x. That comes from that Pythagorean identity, plus 5 sine x minus 4 equals 0. So if I simplify this, 3 sine squared x minus sine squared x gives us 2 sine squared x plus 5 sine x, and then 1 minus 4 will be minus 3 equals 0. So that takes us all the way down to step 3 being correct. The next step after that is to factor. So to factor this, we need a positive 5 sine x in the middle. We would have to have a positive 3 there and a minus 1 there. The outer products will be 6 sine x minus 1 sine x gives us our plus 5 sine x. So the factors are correct. Step 4 is correct. The next step would be to make each factor equal 0 and solve for sine x. So here you would add 1 and divide by 2. Here you would subtract 3. So our solutions will come where the sine of x equals positive a half and negative 3. So step 5 is also correct. So that leaves us with only step 6 being wrong, because there are two places where the sine of x equals positive a half. Pi on 6 is one of them, but the other one would be in the second quadrant, which is 5 pi on 6 as well. So step 6 is where the error was made. They only gave the answer in the first quadrant where there was a second answer in the second quadrant. The non-permissive values for this identity, those come from the denominators. And remember, from the Pythagorean identity, 1 minus cos squared theta is the same as sine squared theta. You can rewrite this as 1 minus sine squared theta over sine squared theta equals cos squared theta over sine squared theta. So your restrictions here are that sine squared theta cannot equal 0, which means sine theta cannot equal 0. And sine, the y value, is 0 at 0 radians and pi radians. So every multiple of pi. And that is why A is the correct answer for the non-permissive values. That identity is verified using x equals pi on 3. Then what is the exact value of each side? So you can do it on either the left or the right. It doesn't matter. So let's just do the left side. We're going to take the sine of 2 pi on 3 over 1 minus the cosine of 2 pi on 3. So where's 2 pi on 3 on the circle? That would put you in the second quadrant with a reference angle of pi on 3. That'll be up there. Where the coordinates are negative 1/2, comma, positive root 3 over 2. So the sine of 2 pi on 3, is root 3 over 2. And that's divided by 1 minus the cosine of 2 pi on 3, which is negative a half. So that'll be root 3 on 2 divided by, the minus minus becomes a plus positive, so that'll become 1 plus a half, or 3 halves. And to divide by a fraction, we multiply by the reciprocal. The 2's cancel, and you'll get root 3 over 3. Had you evaluated the right side instead of the left, you should have got the same answer. And this also could have been done just using the calculator. You'd have to be in radian mode because the angle's in radians. We would take the sine of 2 pi on 3 and then divide it by, I'll have to use brackets here to keep my denominator together, 1 minus the cosine of 2 pi on 3. So that gives you a decimal. It's positive, so that would eliminate A and C. Now you just have to check these two values, convert them to decimal, and see which one matches the answer we just got. Well, the root of 3 doesn't match it. So now we're checking the root of 3 divided by 3 does match it. So you could have used your calculator to find the value of either the left or the right side when x is 2 pi on 3, and then compare it to the answers that you have to choose from. Soccer team plays 6 games in 1 month. Each game results in a win, loss, or tie. For this soccer, how many different sets of results are possible? Well, there's 3 possibilities for each game. There are 6 games, so you can mark down 6 spaces, and there are 3 possibilities, 3 possible outcomes for each game. This is just fundamental counting principle. Your answer will be 3 to the 6th, which is 729. That's where that comes from. In a local high school, from a group of 16 students comprised of 7 singers and 9 actors, a 6-person executive council is selected. How many different councils are possible if the council must include at least 4 actors? So the first thing you need to realize is that order doesn't matter here. They don't fulfill any specific role. So this is a combination. And the word at least means 4 actors or more. So you could have 4 actors, and that means 2 singers, or you could have 5 actors and 1 singer, or all 6 actors. So for the 4 actors, it would be 9C4. Remember, times means, or and means times. 2 singers would be 7C2, plus 5 actors would be 9C5 times 7C1 for 1 singer. Again, or means plus. 6 actors would be 9C6. So if you work out each of these, you'll get 2646 plus 882 plus 84. They add to get 3612. So combinations, because order doesn't matter, and then you have to look at the 3 different scenarios that satisfy at least 4 actors. Prior to 2010, license plates in Alberta consisted of 3 letters followed by 3 digits, and a standard Ottawa license plate consisted of 4 letters followed by 3 digits. Letters and digits can be repeated. There are 23 letters in the alphabet that can be used, as I, O, and Q are not allowed. All the digits 0 to 9 might be used. An example of each license plate is shown. The question says in 2009, the number of license plates possible in Ontario was R times greater than the number of license plates possible in Alberta. What is the value of R? So we'll have to find how many were possible for each province and then divide. Divide the number possible for Ontario by the number possible for Alberta. That'll tell us how many times greater the number was from Ontario. So you're allowed to use 23 letters, and repetition is allowed. So for Alberta, it'll be 23 times 23 times 23 for the letters, times 10 times 10 times 10 for the digits. So that'll give us Alberta. Ontario would be 23 to the fourth times 10 to the third. And to do this, we don't really even have to figure out what each of these numbers are, because you're going to take Ontario's number of license plate and divide by Alberta's number of license plates. You're dividing two sets of powers with the same bases. The 10 to the power 3's will cancel. Then you're just dividing 23 to the 4 by 23 to the 1. When you're dividing powers with the same base, you subtract the exponents and keep the base the same, and you're left with 23. There's your answer. If you actually found the numerical value of each and divided, you get the same thing, but you don't have to. So again, if this was a numerical response question, the first two boxes would be filled. The last two would be left blank. Number 12, the number of 4 or 5-digit pins that can be formed using only digits 2, 3, 4, 5, 6, 7 with no repetition within a single pin is what? So remember, the word or means to add, and obviously order matters, so we're going to use permutations here. So you have 6 digits to choose from, so it's either going to be 6P4 or 6P5. When you use permutations, you're saying that order matters and repetition is not allowed. So 6P4 is 360. 6P5 whoops, I chose C there. Try that again. 6P5 is 720. You add those two together, you'll get 1080. So all 4 boxes would be filled up. In this expansion written in descending powers of x, which is how we normally do it, what is the 6th term? So we use the general term formula. T sub k plus 1 equals nck x to the n minus k y to the power k. And we saw that the value of k was always 1 less than the term number, because if you want to find the 6th term, k would have to be 5. 5 plus 1 will give you the 6. So n is 8, C5. X refers to the first term of the binomial x cubed raised to the 8 minus 5. Y refers to the second term of the binomial, which I would write as 2x squared to the power negative 1. And that's raised to the power k, which is 5. So 8C5. 8c5 is 56. Then you're going to have x to the power 3 raised to the power 3. That's x to the 9th. 2 to the 5th is, well, actually, to do this right, it would be 2 to the negative 1 to the negative 5. So that'll be 2 to the negative 5. And then x to the 2 times negative 1 is negative 2 times 5 is negative 10. 2 to the negative 5th is 32, but it'll be 1 over 32 because you got to make the exponent positive first. So it'll be 56 over 32 times x to the negative 1. And that 56 over 32 can be reduced by dividing top and bottom by 8. That'll give you 7 over 4 x to the negative 1, or 7 over 4x. And that's why B was the correct answer. Okay? There are 6 terms in the expansion of x plus 4 to the n. What is the value of n, and what is the value of the constant term in the expansion? Well, remember that the number of terms was always 1 more than n, or n is always 1 less than the number of terms. So if there are 6 terms, that means n has to be 5. So we can eliminate C and D. So the constant term in this case would be the last term, because the first term will have an x to the power 5. The next term will have an x to the power 4, and so on. So again, the constant term will be the last term. And that will be 5c0. So the value of k, not 5c0, sorry, 5c5. Let me change that. 5c5. X to the 5 minus 5 times 4 to the power 5. 5c5 is 1 times x to the 0 times 4 to the 5th. Try that again. 4 to the power 5 is 1024. So when you multiply those, you'll get 1024, and that's why A is the answer. Okay? So today is your opportunity to rewrite the Unit 2 exam. So if you have your review assignment completed, I'll collect those, have a quick look, and then I'll get you the exam and you can start working on it. For the rest of you, use this time to study. Okay?